Hi, my name is Ariana Berrios, and today I will be talking to you about mosquito fish, ethinylestradiol, and testosterone exposure experiment. So I chose to conduct this study to continue research in an area that is not only in need of more research, but to also give back to the world what it has given to me. We often take for granted how fragile the environment around us truly is, and even small traces of a toxin can have a large impact on the organisms we don't often think about. We must remember that each life has a purpose, and even a small fish has a significant role in nature's life cycle and food chain. With this said, the goals of this study are to learn the effects of estrogen and testosterone on mosquito fish, a known live-bearing fish, as well as test concentrations that can be found in the environment through accidental release. These types of studies pave way for future studies. So a brief introduction, the scientific name is shown. Mosquito fish size, so the females are about 70 millimeters and the males are about 40, with the females being bigger. They typically live in freshwater systems in swampy areas in the southern regions of the United States. Their diets are very diverse and they are viviparous, live-bearing as mentioned before. Regarding reproduction, mosquito fish are live. They typically give birth in spring and summer, and they can give birth continuously for up to 14 days with roughly 40 fry. There's been a great number of morphological changes present when exposed to these toxins. So these changes can include infertility, sex change, smaller body size, and negative impact on the liver, just to name a few. So regarding behavior, though, a study conducted by Dang et al. Found that there was a significant aggression of mosquito fish towards Japanese Madeika fish after exposure to EE2 or estrogen from concentrations varying from 0.5 to 250 nanograms per liter. In order to further this research, both behaviorally and morphologically, I chose female mosquito fish to analyze their behavior towards female least killifish and also expose them to estrogen and testosterone to test the effects morphologically. So here is the 3-day behavioral experiment. I made a test solution by adding 100 nanograms per liter of a working solution to a 2,000 milliliter graduated cylinder. So I created the working solution and I made this concentration shown. I chose all pregnant females and controlled light conditions, and I recorded their behavior. So this is how I recorded it. I timed it in interactions for 5 minutes each, and I compared their aggressiveness towards least killifish, and I recorded. So here are the results of the 3-day behavioral study. On the left shows the standard length. There was significance. The T2 concentrations seemed to be smaller than the control, and the EE2s tended to be larger. There was significance found. Not expected to be found in this experiment on the right shows births, induced births from testosterone exposure. And as you can see, the E2 did not produce any. And here is aggressiveness found. So the first p-value of 0.038 demonstrates the mean aggressiveness, and that is shown on the right in further detail in this graph. And the second p-value of 0.028 demonstrates the mean time to behavior aggressiveness, and that is shown in the orange on these graphs. The 7-day morphological experiment, there were mainly the slight change was the additional 5 nanograms per liter of E2 and T2, and also some were pregnant and some were not pregnant. But I measured the length of the anal fins, weights, and standard lengths in this study. Here are the results. The p-value between concentrations was insignificant for standard lengths. However, when comparing the averages of each to the control, there was a trend reduction in standard length in the higher concentration. This trend was not significantly different. Here's the discussion. So behavioral found decrease in standard lengths, exposure to T2 at 50 nanograms per liter induced birth, and estrogen exposure caused increased aggression. Morphological found a decrease in standard lengths. So to conclude, E2 and T2 may have devastating effects on mosquito populations. As estrogen and testosterone increase, the body length and anal fin size decrease. High levels of testosterone induce early birth in pregnant females. And future research, the effects of T2 on pregnant females, further studies on that, longer studies for behavior, histology in order to further the morphological data, and formulate models to determine how organism level effects translate into population level impacts. Thank you. Here are my citations.